Hello everyone, welcome to ExamPreptool DSA 30 days challenge, challenge number 18. Yesterday we discussed about this problem. Now we are going to see the answer for this, right? So please try to understand what is going on. I hope you tried also. I hope you tried it. So see the challenge number 18, what exactly this problem is. I will give the answer also. Can you see once? One directed graph is given, right? Let me take one directed graph. One directed graph is given. Let's take some directed graph. Whatever way you want, you can write some directed graph. I will give directions within few minutes. I have to give directions. I am giving now. Yeah, I think it is a directed graph. You can see now. I will give the vertices also. It is a A, it is a B, it is a C, it is a D, it is a E, it is a F, it is a G, and it is a H. So graph will be represented either list or matrix. By default, it will be list. Graph will be represented either a matrix or list. By default, it is the list. Right? Try to understand. Try to understand. So in this graph, if you observe, right, there is a cycle. Check. In this directed graph, there is a cycle. If you want, you can verify. There is a cycle in this directed graph. I think some people are asking, sir, where is the cycle, sir? Let's see this one. B, right? F, H, G, and so on B. There is a cycle. If you see other areas, right, no cycle. Look like a cycle, but there is no cycle. Look like a cycle, but there is no cycle. I think one more edge I have to cover. Let me cover that edge also. Let me cover this edge also. I think this edge also let me cover. This edge is not covered, so let's see this one. Is there any cycle other than this? E, E, C, F, H. Yeah, I think there is no cycle. Look like a cycle, but no cycle. Only one cycle is there in this graph. How to identify? How to identify? I will check once. Everyone observe. Everyone observe. I will check once. Make sure everyone. There are so many ways, right? This problem how to solve. I think everyone know. If anyone don't know, please listen once. In the given directed graph, how to find out cycle if it exists, right? The solution for this one is using DFS. You can do it. Using BFS also, right? BFS, DFS both will take same time, right? Same time complexity, same space complexity, almost similar. Let me explain the DFT. DFS, you can do BFS also. DFS or DFT, depth first traversal or depth first search, right? You can do BFS or BFT also. If you are okay with this, you are okay almost with that also. I will explain one algorithm because both are same time. There is no concept of which is efficient. Both will be similar. Some people are asking, sir, how, sir, right? How this algorithm look like? Let me check. Make sure everyone listens. So you have to manage. There are two arrays. You have to manage. There are two arrays. This is the one array. This is called widgeted array. There is one more array. So different languages, different names, but indirectly, directly, all will be similar. It is a widgeted array. It is a stack array. It is a widgeted array. It is a stack array. So some people are asking, sir, what is the size of this particular array? Let's check how many elements are there. 4 plus 4. I think 8 elements. Take one array with 8 slots. Take one array with 8 slots. Right, so for every element of this particular right graph, you can give one index number. right? Maybe index 0 you can give, index 1 also. Assume that A means 0, right? It is a 1. You can give whatever way you want. 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. So I am saying this is the array. Maybe in the Python language it is called list, right? Just names only will change, right? The only thing is same story. Now see this one. Visited of every person initially 0. No one visited. Visited of every person is initially 0. No one visited. And a similar way, no one is there initially in the stack. No one is there initially in the stack. 4 people over, one more 4. Right? Stack contains who are there in the stack as of now. No one is there. Right? Here also, no one is there in the stack. Zeros. If you think that it is effective, you can change the color also. I don't have any objection. Right? Until now, everyone is fine now. Now let me start. Let me start from any vertex. I am starting from A. Listen everyone now. I am starting from A. Remember, I have to use a DFT or DFS. Both are same. Some people will say depth first search. Some people will say depth first traversal. Both are same. Right? Let's see this one. I am starting from here. Whichever vertex you are starting, right? Visited of that vertex. A is the A means 0. Visited of that vertex is 1. And stack also 1. Whichever vertex you want to start from there. But that person visited also 1, right? Next one is stack also 1. Now I think see everyone now. Now what happened is so that A adjacent is B also, C also, D also. Out of them take one person. That's what DFT saying. Now I am at A. Because of you are at A is visited, and A is there in the stack also, because you started from here. It is a recursive procedure. It is there in the stack. Now see this one. I am at here. Adjacent is A adjacent is 3 people. You take any one. Let us say that I will take A to D. I went to the D. So remember, I am at D now. D is not visited because visited of D. D means 3. Visited of D is 0 means it is not visited. It is not visited, so you can go to the DFT here. You can do DFT from here. Again, same story. So, right, DFT of this person, right, visited of this person is 1. 3 means D. At the same time, remember, at the same time. Careful everyone now. At the same time, because of you are at D, at the same story you are doing, D will call further again. So, in the stack also, D, 3 means D. It is also 1. It is also 1. Right? Why I am maintaining 2, you will get to know. I am at D now. D is doing the same story. Visited of D is equal to 1, and it is there in the stack also, because whatever work you are doing here also same thing you are doing. It is there in the stack also. Now can you help me? Who is the D adjacent? Right? Let me check here. Who is the D adjacent? Everyone have to understand. Who is the D adjacent? D adjacent is, I think, E. D adjacent is E, and one more. E means what? 6. It is not visited. So go there. I am at here. So again, same story. Right? Visited of E is equal to 1. And the stack also. E means, I think, 6. It is also 1. I am at here. Right? I am at here. Until now, everyone is comfortable. Please be careful. Now what happened is, right? Again, same. Right? E adjacent is how many people? 2 people. Take one of them. E adjacent is 2 people. Take one of them. So one of them I am taking. So I will go here. Right? See this one. I will go here. Make sure everyone listen. I will go here. Because if it is not visited, I will go here. So I am at C now. Listen, I am at C now. Everyone observe. I am at C now. Again, same. C is visited or not? Not visited. So C means what? 2. So 2 becomes 1. If not visited, visit. And not only that, C should be there in the stack, because see this one. The total green path. The total green path is there in the stack. Right? I think for C also. C means 2. 2 also there in the stack. Those people in the stack, once they are available in the stack, please be careful. Currently, they are available in the stack. The people who are marked as 1 in the visited array, they are already visited. So I am at C now here. So C adjacent is, I think, C adjacent is, I think, if you observe, only F. C to F. and F is not widgeted also, right? I am at here. I am at here. So see this one. F means what? 5. 5 is 1. And one more, it is there in the stack also. 5 became 1. So until now, everything is comfortable. Simply, I am doing DFT. If anyone still not getting, remember, I am just doing DFT, right? And one more to find the cycle. One more story I am using this one. This stack is for cycle purpose. Stack for cycle. And one more, this widgeted array for the DFT purpose. Now I am at F now. Same story. F means what? 5. 5 is widgeted and 5 is there in the stack also. Now again as usual, who is the F adjacent? Who is the F adjacent? I think only one person H. Go there. And one more is not widgeted also. Because of is not widgeted, H means what? 7. Widgeted of this person is 1 and is there in the stack also. Total green path is there in the stack. Total green path is there in the stack. I think this is one answer. This is right. This is there in the stack also. As of now, these many people are there in the stack. Try to understand. I am at H now. Same thing. H adjacent is how many people? H adjacent is only one person. I think this. Only this person. And one more, right? G. G means what? 4. 4 is not widgeted? Yes. Because the 4 is not widgeted, make it as widget. Make it as widget. And one more thing is, right, because if it is not widgeted, I am widgeting now. And one more thing, right, in the stack also make it as 1. G means what? 4. 4 is in the stack 1. Until I reach until, let's see this one, total green path is there in the stack. Okay, until now everyone is fine. Now remember, I am at G now. Same story. G adjacent is B. G adjacent is B, and it is not widgeted also. I came because of not widgeted, I came here. B means what? 1. Because of not widgeted, make it as widget as 1. Okay, is widgeted. And one more thing is there in the stack also. Total green path is there in the stack. So stack also is available. 1 UT. Okay, that is also fine. Now observe. Now observe everyone. I am at B now. Everyone observe. I am at B now. Who is the B adjacent? B adjacent is F. Careful, observe carefully. I am at B now. B adjacent to who? F. Can you help me now? F is already widgeted. F means what? 5. 5 is already widgeted? Yes. It is already widgeted, so I don't want to widget. That is okay. It is already widgeted, it's okay. And one more thing is he there in the stack? 5 means 5 number is 1 in the stack. Yes. Indication that it is there in the stack also. Means you are widgeting the person. See, you are at here. You are widgeting the person who is already available, already widgeted. Widgeting someone who is already widgeted. That is called cycle. And not only that, he is there in the stack. He is there in the stack. See, he is also widgeted. He is also widgeted, but no cycle. See this one. Some people are saying, sir, already widgeting means cycle, na? See this one. This person is here somewhere else. Somewhere else. If you widget the same person again, there is no cycle. Remember, he should be there, right? I'm repeating once again. Not only widgeting the same person again. He should be there in the stack also. Then only cycle. Some people are asking, sir, already widgeted some people, you are widgeting again, can't it be cycle? I cannot give guarantee. Not only already widgeting person again widgeting, he should be there presently in the stack. If not there presently in the stack, there is no cycle. He should be there in the stack. See, he is there in the stack also. You are widgeting again and he is present in the stack also. That is the indication of cycle. That is the indication of cycle. Some people are asking, sir, can you give one example? Can you give one example? Widgeting the person again and he is not there in the stack. Right? He is not there in the stack. Can you give one example? Yeah, if you want, I will give this. See this. Careful. You will get the clarity. Yeah. Now see. It is a A, it is a B, it is a C, it is a D, it is a E, it is a F, it is a G, and it is a H. This is the graph. Everyone observe. This is the graph. This is the graph because of lack of space. Because of lack of space. Maybe I will write the same graph. I will write the same graph in another slide. Right? In the next slide, I will write. Same thing I am writing here. It is a program for this. Within few minutes, I will explain. Right? Within few minutes, I will explain. Let me write the same diagram here. Let me write the same diagram here. I written the program also. I will explain within few minutes. A here, B here, some numbers D, E, F, G, and H. So now see this one, widgeted array, widgeted array, widgeted array, right? Next one. This is going to be stack, right? This is going to be stack. So if you want to can give numbers also, somehow you represent whoever widgeted, they should be marked in the widgeted array. Whoever there in the stack, they should be there in the stack area, right? I'm starting now. Everyone observe. I'm starting now. So start from A. Start from A. A widgeted? Yes. A is there in the stack also. I written. Now after A adjacent people are two people. DFT saying go anyone. I will go here. I am at here. So I think this F also widgeted? Yes. It is there in the stack also? Yes, you right. Now F adjacent is two people. You go anywhere. I will go here. So what is the answer? G also widgeted. G also present in the stack. That is also okay. After G, I will go to H. So H also widgeted. H also present in the stack. Remember the total white line indication that present in the stack. Total white line present in the stack. I am at H now. Listen, H adjacent no one. Everyone observe. Everyone observe. H adjacent is no one. H adjacent is no one because you cannot go this side. F side you cannot go. From H you cannot go to F because see the direction. Because of you cannot go, you have to backtrack. Because of you cannot go, you have to backtrack. You have to backtrack. Remember, backtrack means pop. So it is popped out. See, so this is the difference. Widgeted array and stack, this is the difference. But remember, he is already widgeted. He is already widgeted. He is there in the widgeted array, but he is no more in the stack. Right? Backtrack means pop. Again here also no other possibility. You have to backtrack. Backtrack means pop. You will go here. But remember, G is already widgeted. In the widgeted array, you cannot do anything. Now I am at F now. Now I am at F now. F adjacent who are not widgeted. All are widgeted, so I cannot do anything. Just go back. Just go back. I think F also deleted from the stack. F also deleted from the stack. But one thing, F is already widgeted. In the widgeted array is available. In the widgeted array is available. Please be careful. Now I am at A here. A adjacent how many? I think F also, B also, F over. Now go to the B. I am at B now. I am at B now. Can you give the answer? B is already widgeted? No, widget. And one more. B is there in the stack? No, you can keep in the stack. Is not there in the stack? Keep in the stack. Next one. B adjacent is two people. B adjacent is two people. You can go anywhere. After B, C I will go. C is not widgeted? Yes, keep there. And C is there in the stack? No, keep in the stack also. And one more thing. I am at E now. E is widgeted. See the widgeted array. E is widgeted? No. Then widget. And in the stack area it is there? No, keep in the stack. Now go here. I am at D now. D already widgeted? No, it is not there in the widgeted array. Now next one. D is there in the stack? No. Right? Keep D also. Now observe. I am at D now. D adjacent is B. Everyone listen. D adjacent is B. I am at D now. D adjacent is B, but B is already widgeted. It is already widgeted. And one more thing, not only already widgeting, so he is there in the stack also. That means cycle. Already widgeted doesn't mean that cycle. Already widgeted, not only that, it should be there in the stack also. That means cycle is there. That means cycle. Please careful. That means cycle already widgeted, and one more thing is it is there in the stack also. Then I can say that, right, cycle is exist. Already widgeted doesn't mean that cycle. Already widgeted, that is there in the stack also. Then only there is a guarantee. Then only there is a guarantee. I will give one more example. Already widgeted, but unfortunately it is not there in the stack. Then it is not a cycle. So you can see this. You can see this example. You will get the clarity. Careful this. Yeah. Now you can see this. Is there any cycle here? Please verify. I will start from here. A, B, C, D. A, B, C, D. Please check, is there any cycle? I think there is no cycle. There is no cycle. Now see, if you want, you can verify. One interesting fact you will get. See this one. Widgeted array and stack. Widgeted array and stack. You start from anywhere. I am starting from A. Widgeted array also A there, stack also A there. Afterwards, A adjacent is 2 people. You can go anywhere. I will go here. So C also not widgeted. So in the widgeted array, add. And one more thing, it is there in the stack also, add. After C, I will go to D. D also not widgeted. In the widgeted array, add D. And one more thing is, it is there in, right? You have to add in the stack also. Yes, I added. Until now, fine. I am at D now. D adjacent is going to be, I am at D now. D adjacent is going to be B, which is not widgeted. D adjacent is going to be B, which is not widgeted. Can you see this one? Which is not widgeted. Right? Widget. And one more thing, it is not there in the stack also. Add it. Now, B adjacent is no one. Everyone observe. B adjacent is no one. Interesting answer. B adjacent is no one. So backtrack. Right? B adjacent is no one. Backtrack. Backtrack means pop. Now, D adjacent also no one. So backtrack. D also pop. C adjacent also no one. Backtrack. Right? Backtrack. So C also popped out. Next one. A adjacent is previously I went C. Now I want to go to B. But B already widgeted. B already widgeted, but it is not there in the stack. That means no cycle. You are going to the person who is already widgeted. See, from A you are going to B, which is already widgeted, but is not there in the stack. So it is not a cycle. So I want to say one important thing. Widgeted doesn't mean that cycle. Widgeting the person who already widgeted doesn't mean that cycle. At that time, he should be there in the stack also. If he is not there in the stack, even though you are going back to the old person, it doesn't mean that stack. Remember, going to the person who is already widgeting the person who is already widgeted and presently is there in the stack also. That edge is called back edge. That edge is normally called back edge. Right? Please be careful. Widgeting the person who is already widgeted and at the same time is there in the stack also as of now. That edge called back edge. If back edge is there, cycle exists. Right? Anyhow, I explained very clearly. Remember, 2 arrays you have to manage, or 2 lists you have to manage: widgeted array and stack array. Whatever, right? Whenever you want to keep in the stack, keep inside stack. Widgeting and keeping in the stack. Widgeting and keep in the stack. Whenever no possibility, backtrack. Backtrack means pop from the stack. Backtrack means pop from the stack, and so on. At any point of time, you are widgeting the person who is already widgeted. At the same time, he is present in the stack also. Then cycle exists. So that is the approach. Simply the DFS algorithm, modified DFS algorithm. Modified DFS algorithm. Right? I written the rough code also. I will explain this code. Rough code I written. I am not written exact code. No use also exact code. If you buy hard code, what do they use? See, it is a Python program. It is almost like main. It is the first point. It is almost like main. Right? I will call the cycle function. If cycle function returns 1, right? It is a cyclic. Cycle or cyclic, whatever it is. I will call the cyclic function. If it is returns 1, means cycle exists. It don't returns 1. Right? Cyclic function don't return 1. I will come here. Graph doesn't contain cycle. Right? Graph doesn't contain cycle. Let us assume. So I called the cyclic function. Go there. As soon as you came to cyclic function, remember, as soon as you came to cyclic function, what you have to do is visited of every person initially 0. Visited of every person initially 0. In the visited array, visited of every person is initially 0. In the stack also, stack of every person also initially 0. Let's keep like this. So the all vertices, right, visited is 0 and stack contents also 0 initially. Now what you do is take one for loop, right? Everyone listen, take one for loop, maybe take the one for loop in the range of V. Supposition that number of vertices are 8 assume, right? See, for node in range V, 8, right? Number of vertices are 8. Then it will go to 0 to 7. It will repeat 0 to 7. Right? Node 0 to node 7. Now, for node in range 0 to 7. Right? So now initial node is 0. Next one 1. Next one 2. And so on. 0 means A. Right? 0 means A. 1 means B. Like that 1 by 1 node. So 0th node may be A. 0, right? First node may be B. And so on. Start from any vertex. I am starting from 0th node. That may be A. Then what you do is, see this one. You have to do this one thing. Visited of A, check is it true or false. If it is false, means if not visited, then only you can visit. Right? See this one. If visited of A is equal to false, means if that node is not visited, I started from A is not visited, then call one more function. Because of not visited, then call one more function, cyclic until. So the node which is not visited, A you send. And one more thing is visited array you send. Visited array. This is the visited array. All will be right. All will be zeros. As of now. All will be zeros. And the node I am sending, A I am sending. Visited all 0. Right. Next one is as of now. Stack also 0. Right. Call this function. Right. After everything ready, I took the first person. First person is not visited. Right. And one more in the stack and in the visited array, all will be 0. Because of I got to know one node is there which is not visited, I call the cyclic until. That function I call. If it return 1, then if it return 1 is equal to right true. That is true. Then I will return true. Otherwise, right? Let's go. What he will do? Everything is ready. Let's go. What he will do? Same. Whatever you know, that what he will do. As soon as he came, supposition that A is came. This is A. Remaining things don't bother that much, right? This is the V is going to be A. Visited is all are zeros, right? Stack also all are zeros. All came. Now first step. Visited of whichever vertex it is, that is true. Suppose that it is A, make it 1. And right next one, stack of the vertex whichever you have A, that is also 1. This is also 1. Yeah, completed. Now start the story. I am at A, right? Visited also A value 1, stack also A value 1, everything done. Now A adjacent find out. See, find for neighbor I, for neighbor in right in graph B. So in the range, in this range, all the neighbors find out. I think A neighbors are B and C. Take one person, one of the neighbor. Let us that A neighbor is B also, C also. I will take B first. Now check. Visited of B is equal to false. Yeah, if not visited, right? A adjacent is B and C. I took B. If B not visited, do the same story. Whatever you done for A, B also. In the next round, B will come. Recursion. Now it is B. So visited of B is also 1, if not visited. Right? Next one, stack of B also 1. Then again, B adjacent people find out. Assume that B adjacent is D. So it is D. It's keep on going. It will come here, it will come here, it will come here, it will come. Like that, continue. Some point of time, see this one, some point of time, Visited of a particular vertex is true or false. Check. False. What do you mean? Visited. This is false means visited of my neighbor is right false. If visited of neighbor, if it is false, then no problem. Suppose visited of neighbor is true. This is fail. This is fail means is already visited. If already visited, you cannot call the recursion. If already visited, immediately check here. In the stack is already available or not? Yes. Are you getting? So this condition failed. Indication that is already visited. This condition true is present in the stack also. Then return true. Means indication that cycle exists. You are returning true. That true will goes to where? That true will goes to here. It is true. True is equal to true. True is equal to true. Yes. Return true. This true will goes to where? From here. It is true. True is equal to true. Yes. Graph contains cycle like that. I hope everyone got it. I hope everyone got it. See this one in this code. It is in the program first step. In the program second step. Because it is a call. In the program it is the third step. Right? In the program it is the third step. In the program it is the third step. Suppose is you. Right? So already visited. This condition fail means already visited. Already visited means this condition fail. So I cannot go inside. Come here. Now check. Stack contain is he there in the stack? Already visited. Is the there in the stack? If it is there in the stack, already visited cycle. Suppose already visited, it is not there in the stack also. Then you will come here. So what is the answer? This is going to be false. That is the indication. This indication that it is false. This indication that it is false. Return false. Means cycle not exist. Other than this, nothing. That Python, right? It is a Python program. You can write whatever language you want. In the Python, gaps are more important. See this one. Here, all are working inside for loop. It's outside for loop. Right? It is outside. That means inside this code. Inside for loop is this area. Inside if is this area. So everything is through gaps it will work. I hope you got it. It's one of the famous problem of DFT, BFT. Finding cycle if exist in the given directed graph. Important thing is remember there are two arrays we are managing, visited array and stack array. So the size of this one is how many vertices are there, that much. The size of this one is how many vertices are there, that much. So extra space, auxiliary space you are taking. Extra space means auxiliary space, which is called space complexity. So V space. What about time complexity? Total graph you are visiting one time. So I'm writing now. Right? I'm writing. Time complexity of this program. If list adjacency list order of V plus E. If it is a matrix, order of V square. How you represent the graph? If you represent the graph by list V plus E time, matrix order of V square. What about space complexity? Array extra space. Two arrays I am taking. Right, visited array and stack array, right? V plus V, 2V, which is nothing but order of V. That is the answer for this. Using DFT item. If you try properly, DFT also possible. If you want to finish this entire story within single line, how you find out in the given directed graph cycle exists. Apply DFT if you find out one back edge also. What is the meaning of back edge? Visiting the person who is already visited, that edge, whatever is there. And one more thing is, at that time, that vertex should be there in the stack. That edge is called this edge. See, if you want, you can check this one. You came like this, you are at here, you came like this. Sorry, you are at here, you came like this. This edge is called back edge. See, from here, you are visiting one person who is already visited. At that time, he is there in the stack also. This edge is called back edge. If back edge exists, right, after doing a DFT, then cycle exists. Right. That is the answer for this. I hope you are I hope you are enjoying. I hope you are learning. If you have a small doubt also, in the comment section, you can write. Thank you so much. Thank you so much. See you right with the next challenge in the next class. Thank you.